Picture this. You're looking at your hand right now, and you think you understand size. You measure things in inches, feet, meters, all based on us, on human biology. But what if I told you that every single measurement you've ever known is completely meaningless when it comes to understanding the true scale of reality? That the universe operates on dimensions so mind-bendingly extreme that your brain literally cannot process them? I'm about to take you on a journey through the most incomprehensible scales in existence, from the impossibly tiny to the infinitely vast. And by the end, you'll realize something profound. We might not be as insignificant as we think. Let me start with something that will absolutely blow your mind. Forget about inches and centimeters for a moment. What if aliens visited Earth tomorrow? What measurements would we both understand? What's the universal language of size? Scientists have identified 3 fundamental constants that any intelligent civilization would recognize. First, the speed of light, that ultimate cosmic speed limit that nothing can exceed. Second, the gravitational constant, the number that tells us how strongly massive objects pull on each other. And third, Planck's constant, which reveals the granular quantum nature of reality itself. When you combine these 3 universal constants, something magical happens. They give birth to what we call the Planck length, the smallest meaningful distance in the universe, and this is where things get absolutely insane. The Planck length is 10 to the minus 35 meters. That's a decimal point followed by 34 zeros and then a 1. To put this in perspective, imagine taking a single proton, already unimaginably small, and expanding it to the size of our entire solar system, stretching it out to Neptune's orbit. Now, in that vast, scaled-up proton, the Planck length would be the size of a single biological cell. But here's the truly mind-bending part. If you want to see something that small, you need to shine light on it. But quantum mechanics has a cruel twist waiting for us. The smaller the thing you want to observe, the higher energy photons you need to use. When you try to peer down to the Planck length scale, you need such incredibly energetic photons that you literally create a black hole in the process. The universe itself prevents you from looking any smaller. It's like nature has installed the ultimate privacy screen at the quantum level. Now let's swing to the complete opposite extreme. We humans exist in this middle realm, a few feet tall, living on a planet that's about 8,000 miles across. We can maybe wrap our heads around traveling to the moon, which sits roughly 240,000 miles away. That's comprehensible because we've done it. But even our sun, sitting just 93 million miles away, starts to strain our ability to truly grasp distance. If you could somehow drive a car to the sun at highway speeds, it would take you over 100 years of non-stop driving. And our sun is tiny compared to what's out there. Think about Voyager 1, humanity's most distant ambassador, launched back in the 1970s. It's been racing away from Earth for nearly 50 years, and it's now so far out that radio signals traveling at the speed of light take over 22 hours just to reach it. 22 hours for light itself to make the journey. That spacecraft is approaching the edge of something called the Oort cloud, the outer boundary of our solar system's influence. But we're just getting started on this scale journey. Our entire solar system is just a tiny speck orbiting within the Milky Way galaxy. This galactic merry-go-round contains somewhere between 200 and 400 billion stars spread across 100,000 light-years. When you look up at the night sky away from city lights, that misty band stretching across the heavens is you seeing our galaxy edge on from the inside. And then there's our nearest galactic neighbor, Andromeda. The light you see from Andromeda Galaxy started its journey toward Earth over 2 million years ago, before humans had even evolved. That photon of light has been racing through the vacuum of space since our ancient ancestors were still figuring out how to use tools. But we can see much, much further than Andromeda. Using our most powerful telescopes, we can detect light from galaxies so distant that it has traveled for over 13 billion years to reach us. Think about that. Some of the light hitting your telescope tonight began its journey when the universe was barely 500 million years old, long before Earth even existed. Here's where it gets really wild. Because the universe has been expanding this entire time, those distant galaxies that emitted the ancient light we're seeing today are now actually about 92 billion light-years away from us. The observable universe, everything we can possibly see, stretches about 92 billion light-years in every direction. But here's the kicker that will keep you awake at night. That's just as far as we can see. The actual universe might be infinite. Literally infinite. No edge, no boundary, just endless space filled with countless galaxies stretching on forever. Your brain rebels against this concept because infinity isn't something we evolved to understand. So when you consider these scales, from the Planck length where reality becomes fundamentally quantum and uncertain to the potentially infinite expanse of the cosmos, it's natural to conclude that we're utterly insignificant. Just a brief flicker of consciousness on a tiny rock, circling an ordinary star in an unremarkable galaxy in an incomprehensibly vast universe. But here's where the story takes a beautiful turn. Recent thinking in physics and cosmology suggests we might have it backwards. What if the fact that we exist to observe and contemplate these scales is itself profoundly significant? Consider this. If intelligent life can persist long enough, if civilizations can survive and grow and spread across cosmic time, then consciousness itself might eventually span galactic scales. Life might not always be confined to tiny biological specks on isolated planets. Perhaps consciousness could someday influence the evolution of entire star systems, maybe even galaxies themselves. This isn't science fiction. It's a serious proposal by some of our greatest thinkers. The idea is that if life becomes truly long-lived and technologically advanced, it might transcend its humble biological origins and become something that operates on astronomical scales. Instead of being dwarfed by the cosmos, intelligence might eventually reshape it. From this perspective, we're not insignificant accidents in an indifferent universe. We might be the universe's way of understanding itself, the cosmos developing the capacity for self-reflection and conscious purpose. Every time you look up at the stars and feel that sense of wonder, you're participating in the universe's growing awareness of its own nature. The scales that rule our universe are indeed incomprehensible. From quantum foam at the Planck scale to the potentially infinite cosmos, we exist in a reality that stretches far beyond what our minds can truly grasp. But perhaps that's precisely the point. Perhaps consciousness, intelligence, and wonder are not bugs in the cosmic code, they're features. We might be small in terms of size, but we're enormous in terms of significance. We're the universe contemplating itself, measuring its own vastness, and dreaming of futures where intelligence isn't confined to tiny biological forms on scattered worlds, but becomes a cosmic force in its own right. The next time you feel overwhelmed by the sheer scale of existence, remember this. You're not just observing the universe, you're participating in its evolution towards something unimaginably magnificent. And that's a thought worth holding on to as we continue our journey through the cosmos, one incomprehensible scale at a time.